limitations of the monolith architecture, because in this case, we will also have uh, some sort of like physical resources limitation, because um, Java by itself requires a lot of resources. So a lot of CPU, a lot of RAM, it just eats it up like completely. So for that reason, it will be very hard to maintain that compared to using the same Java application, but only in the microservices architecture. So through slightly different approach. So these are basically the four main limitations on the monolith architecture. So now let's talk. Oh, that's a good gift. So this is basically how it feels like when you work with the monolith architecture. When you have a huge code base, when you have so many code lines that sometimes you don't even you stop forgetting what these lines means, and new developers that are coming to your projects really afraid of this project because there's so many lines of code, there are so many files, and you know this bear literally describes how I would feel and how I felt myself when working with the monolith architecture. But now let's talk about the advantages. Uh, as I said before, there is no like silver bullet that can solve all of the problems, because again we must take into account that technologies, um, any type of technology, any type of approach for architecture has pros and cons. So for that reason, when choosing which architecture or which approach, which technology to choose, I would always look at our goals. I would look at our priorities, our resources, our budget. There are actually a lot of variables that you need to keep track of in order to understand um, which technology or which architecture to choose. So here are the advantages. So the first one is fast development time, which basically means that uh, it's incredibly fast to create an app with this architecture, because you don't need to care of of the infrastructure of different relationships between different servers, proxy servers, etc. You just write your code, you just compile it, and it works out of the box. So this is good, for example, for small startups, for medium or small businesses that need some simple solution that will that will just fix some problem, or that will just automate some problem. And for these reasons, it's pretty much okay to use monolith architecture, or even let's take as an example a block platform. So this can be some sort of a monolith architecture. Even if we take at the WordPress itself, it's like a whole huge monolith application, which consists of ton of files. And in case of that, that's pretty fine to use WordPress, because it does solve the problem. It's very fast to develop the app, because basically they put everything into one place. They put backend, they put front end, they put UI, they put admin panel in one place and called it WordPress. So with that approach, it really works, and there are so many cool website built with the WordPress, and that's just yet another reason why I told that there is no silver bullet. So as we might see, that's where the monolith architecture may shine. So the WordPress is a good example of it. So the second advantage is very easy to work with. So again, you don't have to care about spinning up a web server. You don't have to think about Docker configuration. You don't have to know networking, because all you need to do is basically some virtual private server or like shared hosting to upload your app, and it will be up and running like within seconds. So the third advantage is less configuration, which I basically already mentioned. And the last one is it's easier to test and debug monolith architecture because when it comes to testing and debugging, microservice architecture is sometimes pretty tricky to do end-to-end testing because you have to set up some additional environments between these two microservices to make everything work. So for that reason, when working with the monolith architecture, it's always much easier to test and debug things. So let's go further. Now let's take a look at what do microservices offer. So first of all, they offer you a scalability. So with the microservices, you can easily scale your app between different regions of our planet, and especially with the Kubernetes, you can set everything up in such a way that even if some microservice go down, it will be automatically healed and it will be up and running again. So it's really cool how microservice architecture and these uh, technologies like Docker and Kubernetes help you scale your apps because previously uh, you would have to do so much manual work to scale databases, to scale even simple web servers like Apache or Node.js between different servers. There was like everything was done by hand, and that was like a really nightmare. But with the help of Docker and Kubernetes, everything is simplified, though it's at the cost of time because you have to put a lot of effort and time to get to know Docker and Kubernetes. And but eventually, you know, if you choose to learn these technologies, they will definitely bring about a lot of opportunities for any of your projects. Of course, in case if you need a microservice architecture. So the second advantage that microservice offer is separation of concerns. What it basically means is, let's refer back to the CRM system. So uh, if we had chosen to use the monolith architecture, then we would basically put any type of business logic, any type of functionality inside one Java project or inside one C++ or PHP, doesn't matter, project. So we would basically really have everything uh, closely related and highly dependent on each other, and that actually raises another reusability issue that we talked already before. And with microservices, you can separate the functionality within one monolith app into different microservices that you might then reuse in any of your project. And that's the beauty of the microservices, is reusability, which is the third advantage that microservices offer. So it's really cool that all of our efforts, they don't fade away once they finish working on this project. So if we choose to use microservice architecture, then rest assured we will be able to reuse this code in other projects. So for example, notifications API is one of the examples. So we might create, even within notifications functionality, we can create, three more microservices. For example, WhatsApp notification API, then Slack notification API, email notification API, etc. And we'll be able to reuse that same functionality in all of our projects. So reusability is one of the, I would say, topmost advantages that microservices provide you. So the next advantage is reliability. So as I mentioned before, with the help of Kubernetes, it's very easy to make sure that all of your microservices are on. So even if they die by some reason, so if there is, for example, uncaught exception, which may happen, so it will reload it, redeploy it, and it will be up and running. And it will be very easy to create multiple instances of your application and set up a load balancer to direct the traffic between these different replicas of the same application. And Kubernetes and Docker really take care of the reliability, and they do it really very well. So the next advantage is the new opportunities. So when we were talking about the monolith architecture disadvantages, so we talked about bad technology choice. So which basically means that, again, if we um, which basically means trying to solve all problems with one language that you know best. But with the help of the microservices and with the help of a huge community, it's very easy to find some open source uh, solutions that may work for you. No, you will have to do is to run a couple of CLI commands to make this service up and running. So this is really cool because it drastically simplifies and speeds up the development process. And so these are basically top five advantages that microservices offer. And speaking of reusability, here is like it can be written in one line, of course, but for the sake of clarity, it's written in the 4 lines. It's just an example of how you can basically spin up a proxy server within like 4 lines of code. You just need to paste them into your CLI, and you will have a proxy server up and running like immediately. So isn't that cool? So this is really when I firstly realized it when I was getting acquainted with Docker and microservices. I was so surprised, like how come. So previously I was like wasting hours to set something up, or to set, for example, proxy server up. Now I just need to copy and paste a few lines of code, and it will be up and running. So that is the future. That 100% a future of the development, because that brings about so many opportunities. And as you may already notice, that it's not about only your application that may take advantage of microservice architecture. It's also your environment, your development environment that may take advantage of this architecture. Because again, you may spin up some servers or some applications within just a couple lines of code, and that's really cool. So but it's still pretty not obvious when we need to switch to the microservices, because again, we already know that you know both approaches, they have both have pros and cons, um, both have advantages and disadvantages. And let's take a look at when we need to migrate to microservices architecture. So the first case when we need to consider that is when we see tight coupling. So the tight coupling basically means that uh, some subsystems or some separate functionalities within your app are tightly dependent on each other. And again, that's also not relevant to the architecture side, but also for the programming side, because in programming, tight coupling is also a huge issue. So for that reason, if you come across the feeling that there is a tight coupling between different parts of your applications, so that's the time that you might want to consider a microservice architecture. So uh, the second case when you might want to or might uh, take a look at microservices is load issues. So if your website has a huge load, of course we're not talking about a static website that can be uploaded to the CDNs, and these CDNs will take care of the load balancing, etc. We're basically talking about some backend, some really cool backend stuff. And if your application faces some load issues, for example, if it just goes down, if you have a lot of users, or like some other performance issues, you definitely need to take a look at the microservices, because with the microservices you can spin up 4 or 5 or however you want, how many you want, web services or replicas of your applications, and let Kubernetes decide what to do with them. I mean, to take care of them, to heal them if they go down, etc. So another reason why you might want to switch to the microservice architecture is in cases where your app needs to provide an API. So uh, that is really good reason to take a look at the microservices, because, well, in my practice, I've had experience. Well, let's go back to our example, CRM system. For example, let's say we want to let other applications to integrate with our CRM system. So if we put everything, uh, the whole API functionality inside uh, our existing application, that will add like additional, you know, uh, load, and it will take even more resources on our virtual machine, and the whole code base will be even bigger, and for that reason, it will be harder to maintain that. So, but in contrast, we could create just the same Java application, but it will only provide the API for any third-party solutions. So, and that will be the microservice architecture will really help you that. And with the help of Docker, it's very easy to set up a copy of that server, which is, for example, they will both use Java. And with the help of Docker, you can create a network between these two containers, or like, let's say, applications. A network which will help these two microservices talk to each other like very easily. So, mm, but having to move API to a separate project will actually introduce separation of concerns, so that uh, the first project will contain everything that is needed for the business logic of your application, and the second app will be responsible for providing and exposing API to third-party application. It has so many tasks to care about, like rate limiting, like security, authorization, authentication. There are a lot of things that API server needs to take a look at. For that reason, so if you feel like your app needs to provide some API, maybe it's time to take a look at the microservices as well, because putting everything together can be overwhelming, like for in a lot of cases. So the last reason why you might want to when you might want to take a look at microservices is high amount of services. So we already talked that our CRM system could have some notification system. It might also have some billing system. It might have a real-time communication system or like service. So if you feel like your application provides or consists of uh, some of the services that may exist separate of each other, then it's also a good reason to take a look at microservices, because you can basically create a web server, I mean, like a Docker container for each of them, which basically will create a microservice for each of these services. It will be much easier for you to reuse uh, your functionality and distribute the load between different services, which is also very, very important. So this is pretty much it. So speaking, this is like the last slide that I've got, like an architecture example of microservice architecture. So just simple stuff. For example, we have an Node.js application, which is like a Docker container, which connects to the MySQL database, which is also a Docker container. Then we have a Java API, which connects to the Node.js notifications API, and which by itself also connects to the MySQL database. So let's sum up. And so I would basically uh, to specify uh, one a couple of advantages of microservice. I would say the first one is scalability. It's really it's much easier to scale your application with microservices architecture. The second one is reusability. Well, these two things, that's already enough to consider going to microservices, because you have to do so many things. You have to be concerned about so many issues when uh, dealing with any of these things separately by hand. So for that reason, microservices, they really, they actually can definitely help you reduce the load and and reuse the stuff, reuse your functionality, because that's very important. And at the same time, reusability actually also means that even all of the other applications that depend on that microservice, they will always update the latest version of this microservice, because uh, these applications, so they will basically communicate with your service through HTTP request, which basically means that these apps, they don't have to be recompiled to get new functionality. So they will just, send the regular HTTP request to your server, and your server will be already the latest version of your service. And that basically comes to, I would say, to two pillars for the microservices. So reusability and scalability. So these are basically two things that really stand for the microservices. And speaking of the monolith architecture, I would uh, I would stick to the speed of development and debugging and testing. So whenever you feel that you need to do something really quickly, so it's probably the best way to start from the monolith approach. And because the speed of development is barely compared to the microservices architecture, because in microservices you need to take care a lot about the configurations and networking as well. But uh, you know, microservices is not also about the architecture. It's also about the way you think about your code, the way you think about your code base. For example, uh, within that CRM system, you might want to, instead of having to put everything in one place, uh, you might uh, you might separate it into several different sub projects that are closely related to each other. And that's like an application level microservice architecture. When you, I would even say a code level microservice architecture, when you basically uh, divide your application into several sub applications, even at the coding phase. It's not like at the continuous integration or continuous deployment phase. It it actually may happen during the code phase. So when you program, it actually has to do a lot of with how good and well you're familiar with the best programming practices. For example, if you know the solid principles, which is again all about having reusing your code and having uh, a loose coupling between different subsystem or submodules of your application. So I would say that in any case, no matter what you want to choose, or if you're hesitating what you want to choose, you must strive to first to try to make your code as good as possible. So make it modular, make your code reusable, even at the level of functions, because even a function can be a microservice. So uh, before switching to microservice architecture takes a lot of time. That's a long journey to go through because you have to know Docker, Kubernetes, networking, etc. But to start right here and right now, uh, you will basically need to uh, try to separate your application into different services, make different parts of your code as much reusable as it possible so that you can reuse it everywhere. And once it's ready on the code level, it will be way more easier for you to create a microservice architecture. And even sometimes in my practice, and you can definitely go through monolith to microservice architecture. But if initially you didn't take care of the tight coupling, then it will be really very hard to switch to the microservice architecture. So for that reason, even if you start from the monolith architecture, uh, you need to take a look at reusability and taking care of loose coupling between different functions, classes, or like modules of your app. If you have this approach, then transition to the microservice architecture will be much easier for you because it's not only because there's less work. It's first of all is the mindset that you will have when dealing with the microservices. So mm, there are actually a couple of more points that I would point out when dealing with the monolith architecture. Uh, One of the limitations that I would really point out is the complexity of the code base that may grow up really extremely fast. And that actually increases the entropy of the project, which it makes harder for the developers and especially for the new developers to work with this code base, to maintain this code base, and to work with that. So regardless of which architecture you choose, uh, try to take a look at the best coding practices first, because that will help you. Again, that will create a special mindset in your mind of reusability, of consistency. That will help you. Well, that will drastically help you to come around with the microservices architecture and when getting to know Docker, for example, or getting to know Kubernetes. And speaking of the sequence of technologies that you need to learn, so the first thing that you might want to learn is Docker for sure, because Kubernetes depends on the Docker or on some other container application, but Docker is one of them. So the best way to start is uh, learning Docker, how to use it, how to build it, and that will be like the easiest, the best way to start with the Docker. And of course, if you consider working with the microservices, you should also need to improve your Linux commands because you need to know. pretty much a lot of them in order to make sure that everything is set up, in order to know that networking is okay, etc. So that's pretty much it from my side. I'm wondering if you guys have some questions. So thank you. Thanks for your attention.
Yes, Sansa, can you hear me?
Yeah, yeah, I can hear you.
Oh, perfect. First of all, thank you so much for this wonderful presentation. I
My
think,
pleasure.
oh my God, Wait, oh, is the echo gone now? I think I was getting some echo or something.
No,
Can you hear
no,
me?
at least I didn't hear it.
Oh, okay, great. So I think I've been to digital marketing space for some time, and I read about I was trying to understand. After your presentation, I think some things are getting more clearer. So thank you so
Mhm.
much for that. And I think it's like the things which I learned from your presentation today, from your
Mhm.
expertise and the thing which you've shared. It's like when you get started, you can start with monolithic because it's easy to like get
Yeah,
started with
that's right.
monolithic.
That's right.
But it's
Mhm.
like when you start to grow up, then there might be an inflection point where you would want to
Mhm.
maybe switch over to microservices,
Yeah, that's
right?
right.
So
But
my question,
yes,
yeah,
for any type of business, for any type of startup, it's very important to build fast. It's very important to have the product like tomorrow or even yesterday. Sometimes we have cases like when we need this product yesterday, and of course, in that cases, getting starting from like a monolith architecture is pretty much okay. Uh, but again, you know, we must stick to the best programming practices, because even if we have like huge, like complex microservice architecture and the code base is very poor, it's not like maintainable, it's very slow. It's microservice will not solve the problem. So I would say like first thing to look at is best programming practices. So that will help. That will drastically help to yeah, to switch to microservices once your business or startup grows up.
right, right. So I think what I'm learning from this is like if there's anyone who has a business or something, they're into coding. First of all, their base should be strong. The fundamentals should be strong, and then you can think about about the transformation and the transition from monolithic to more microservices. So,
Yeah, that's right.
so
Hmm.
my question would be how do you decide, let's say Sandar, if you are a business person, you are a
Hmm.
startup, you are building an application, how do you decide, or what are those pointers which would
Hmm.
indicate to you that now is the time where I might need to shift from monolithic to microservices? I mean, how would you decide, or what factors would influence that decision for you?
Hmm. Well, there is no silver bullet for that, unfortunately, but Uh, basically, it all depends. As I mentioned, there are so many variables that you have to look at. Just look at me. I've had 5 startups, and all of them failed. There's basically, so software knowing best programming practices does not guarantee that your business will succeed. So we have to look. So if you are like an engineer in this company, you have to be in the close contact with the CEO, and you must know the status of the company, their priorities, their plans. You have to know priorities, resources, and goals. That's what you must need to look at. If, for example, uh, CEO says you we have a ton of time, but I need from you to create the best possible application ever, which is very rare to hear, because we always needed like to develop apps fast. But if CEO says that you have time, it's better to come to this question very seriously, to make architecture first, like architecture driven design, and then but it will be much slower. uh, but if you need to have the product soon, or like the deadlines are short, then we have no choice other than starting from the monolith, application architecture. But again, um, best program. So definitely need to know the status of the company, the priorities, the resources, and stick with the best programming practices.
Yeah.
And and but let's look at this. Ideally, if everything goes fine, as is answering your question, so where should I personally decide when to switch? So I would basically switch right before taking a decision to add a new feature. For example, speaking of our CRM system example, if after daily stand up, our SEO says that we need to have a messaging app or we need to have a notification app, that's the point when I will create a new branch of our application and start working on that. And it's very important to stick not only programming patterns and paradigms, but also to the software management paradigms. For example, working with the help of agile principles, or working with the scrum, where you basically, when you create an MVP, which is basically the simplest version of your project, which can be a monolithic app just for the beginning. And then uh, as new requirements, as new features come up, that's where you decide if that should be within this code base or if that should be outside this code base. But it's better to split everything up.
Yeah, yeah. I think that makes the decision. I think these factors of this answer would help people who are into this dilemma. And I think it's like when you're wanting to make things more modular, like different things. There's a question in the Q&A section, and the question is from Melissa. If it is many services, is it
Mhm.
not too expensive on infrastructure?
Oh, of course it's add up some cost to that. It's definitely, but when we're talking about a business side, it will actually can be easily covered with the profit that you get from the clients.
Oh,
So, or like if that's some sort of important service where users want to have your app online 24/7, then you cannot let your app down by no means. So for that reason, that will be some sort of investment to get the respect and uh, to get the respect from your clients, respect and love from your clients.
right. Yeah, I think so. That would also require like sort of an ROI study, return on investment study,
Mhm.
before you could invest that. So there's one more question regarding these lines, and this question is from Juan Sanzar, and Juan is asking, any suggestion to migrate from monolithic to microservices? How can
Mhm.
we start? That is the question from
Mhm.
Juan.
Well, great question, Joan. So, first of all, I would take if you already have an existing monolithic app, then first of all, ask yourself, does it work? Does it work well? Uh, does it satisfy your current needs? Uh, so if it satisfies your current needs, if it works well, if it doesn't fall down, then probably you don't need to switch to microservices because we build things not for the sake of building or making something complex. We build apps to solve our real life problems. So if it works for you, if it solves the problem, uh, so then you probably don't need that. But if you feel that you need that, try to take a look at try to differentiate your application, try to create some abstract modules of your application. For example, in case of the CRM, you might want to find some like notification module, so probably I would put that module into separate microservice. Then you would find some billing API like or billing module. Then I would so basic it's like playing Lego when you build stuff with small blocks with small building blocks. So Your task is to, if you want to switch to microservices, you must divide your application into these small building blocks that your application consists of. And for each of these building block, you will need to create a separate microservice. But again, you must first of all follow probably the first thing that you might want to do is to do some sort of refactoring in order to decouple things, decouple modules, functions, classes, etc. So the first thing that I would want to do, if I would understand that I need to do some improvements, and that if I saw that there is a tight coupling, I would do some refactoring, so in order to make the loose coupling. And then I would divide into different subsystems, but not too much. There's no need to, move every function into separate microservices. Absolutely not. We just need to have an abstract division. For example, I think it's clear that email notification service can be, a separate app. It can be outside the CRM system. So ask yourself, can this piece of code or can this module exist independently? If it can, then you might want to create a microservice. But you might also not want to do that because probably, again, if you have plans to not reuse it in the future, you might isolate it within your code or make your code loose coupled. And then when you need, you might want to migrate to the microservice. So even if you see that there is something that can be a microservice, it's not enough to switch to that, because again, you must take a look at your budget, you must take a look at the priorities, at so many things. But answering your question, ask yourself, can this exist independently? If can, then probably it should be a microservice.
Wow. So I think that is like, if I had to sum that up in one line, I think I can say, if just because it can be done, it should not be done, right?
Sure,
So
because that's a lot of development time. That's a whole of also experience that you might have to. These are not like easy things to get do. You must be some sort of a seasoned DevOps engineer to make sure that everything works. So it will definitely takes a couple of years to get to know that. But the best way to start working with that is learning Docker, because you may learn Docker within a few months or even within 1 month and start using that in your projects. So Docker is a great place to start from, because you may use it like in the next month.
right, right. So there's one more question stands up, and the
Sure.
question is, yeah, if the question is, if we use microservices, how
hmm
could we make these services talk to each other? Do they need to use the same database or what?
Oh, database and microservices, that's a tricky topic, because actually there is no way for when we're dealing with the Kubernetes, it's really very hard to to take care of persistent data storage. So for the database, probably you might not want to create several replicas of your database. That will bring about a lot of issues, and probably it's not the best choice to move it to micro. But database is already a microservice itself. I mean, you should not spin up a lot of replicas of that. And for the database, you probably might want to have um, a good server. So database must definitely reside on a separate uh, virtual machine with enough resources to process the load. So if it's not enough, then you have to scale it with the means of this database. So choosing to scale it with the means of Kubernetes may bring about issues with the data storage, because some of the data might get lost if your database get closed or gets shut down by some of the reasons. And uh, so what was, could you please also, I forgot the second part of the question.
Yeah, yeah. So the second part of the question was, for microservices, these services should talk to each other, communicate
How
with each
they
other.
can talk. Yes.
Yeah.
For example, it can be done on the Docker level. So in the Docker, you can create a network, and for each container, also known as microservice, for each container, you can assign a network that it can work within. So, for example, you have Node.js, Java applications. With the help of Docker or Docker Compose file, you just assign them a specific network, like one network with the same name, and they will be able to talk each other. And the cool thing about it. They may talk each other not only through the IP addresses that exist within this network, but also by their container names, which is really cool. So instead of like writing the IP address, I may just HTTP slash slash Node.js. That's it. That will be enough for the Docker to understand what you mean by that.
Mhm.
So it's you can do it with Docker configuration or within Docker file. It's really just a couple of lines.
Well, I hope that answers your questions, guys. And I think we are coming to a close of the event. But just in case, if you have if you had more questions, I'll feel free to reach out to us at support@turing.com, which I'm just mentioning it in the chat box. And if you have any questions, guys, feel free to put them. I know experts like Sanzar are there here. I know they are here to help you and add value to you. So I think we will be about to wrap up the session for today.
Mhm,
And okay, so Eric, there's a long question. To sum
mhm.
up, in the specific case that the load or there are tons of queries to balance are not the typical databases or APIs or web service issues, but it is that an app of a single page or view that has a lot of HTML content. I mean, is it possible that many PCs, machines, AWS instances load different parts of the same page? That's a very long question, Eric, but I hope
It
did
can,
you, were you
sure,
able to hear?
definitely. For example, you can create a simple HTML page which references style sheets or scripts from different servers. So this is, but the HTML file itself will be served through one server. But with the help of new technologies and APIs, you can stream HTML. That's like a recent cool feature that we have. Uh, React library actually helps you do that to stream the HTML. So answering your question, so we cannot uh, we cannot serve uh, one file from different servers, but uh, within one HTML we can load scripts, style sheet from different servers for sure, because it's for you to decide where you download these files from. But in case of, it's not related to the HTML, but in case of peer-to-peer network, for example, like something like a blockchain or like torrent stuff, uh, this can be possible. But of course, it's outside our topic. But theoretically, this type of things possible, but not within the web technologies. Not web technologies, within the HTML.
Awesome, awesome.
And
So
I think I can add up. So speaking of your, so I think one of the most interesting thing is having to load infinite Excel sheet. So you can basically do that with the help of JavaScript or cool JavaScript libraries like React or Angular. So I prefer React for that. Uh, there is you would have to add up some client side logic in order to make this happen. You will have to add up some uh, scroll event listeners so that once you scroll to the down to the bottom of it, you will send a post HTTP request to your server, which will get the next 10 rows of this Excel file and then append it to your HTML, so etc. So it's matter of the client side logic. I hope I
awesome.
answered your question. Mhm.
Yeah, I think that was a fantastic question and a fantastic answer to it. And
Yeah,
just before we wrap up, thank you so much, Eric, Gali, Juan, Sukulehu, Edward, Juan, everyone who joined us. Thank you so much for your time. And just before we go, Sanzar here is under so many startups. He has never gave up. He's always kept on learning and improving. So,
yeah.
Sanzar, I would just like to wrap up this event by requesting you to share your advice, what motivates you, and if there's any developer who feels like they might not be getting their dream job, they're still waiting, or there's something pulling them back, they're feeling demotivated. What would be that one advice from your 8 years of experience as a developer, as a software developer?
My best. So stick to best practices, and make sure that your code base is loosely coupled, so that you can reuse stuff. So this is one of the best. And speaking, there are actual. This is too many things. Take care of loose coupling. Make sure that you know things exist independently, so that you can reuse stuff across your projects.
Great. Great. And just a general question, Sansa, when when
Mhm.
something you figure, you thought that it will work, it doesn't work, how do you motivate yourself to work, come back? I mean, how do you
Well,
do that to yourself?
that's a great question. Do you know I'm type of person that really strives to get the answers? I like, and that's also in addition to the previous question. You should always strive to look at the root of the problem, because
Oh,
when you know the basics, when you know the roots, uh, all of the other, probably all, many, if not all answers, will be in your head. So I actually myself, I spend a lot of time doing research and development. You should, oh, if you're a developer, you should definitely learn like a lot every day. That's what I do. I program, I do my work, and I learn stuff. I choose new technologies. So learning is very important skill, 100%.
wow.
And yes, you should be willing to look at the root of the problem.
Root cause analysis. Got it. So I think that's a beautiful sum up, Sansa. I think I also am motivated by Sansa. And being a motivational speaker, I'll just end up with a few lines which I wrote some time back. Guys, if
Mhm.
you ever feel like once you get hit, right? Once you get hit and you feel like shit, then don't worry a bit, because you guys got the kit to come back and become super hit. So that's all from my side. And thank you so much, Sansa, and everyone joining here.
Yeah,
That's about
thanks.
it. Yes, Sansa.
I hope
Any
I also was
closing?
useful for you guys, so for taking your time. I hope you got some of the insights, and I'm not less excited to getting to know you, and not less motivated to get to know you guys. So I'll be really glad to host maybe some other events on different topics. And the questions were really great. Thank you guys.
Yeah, that's awesome. Thank you so much, Sansa. I'm very I'm
My
very sure
pleasure.
that
My
insights were
pleasure.
awesome. Thank you so much, guys. And because this event is also going on YouTube, feel free to subscribe to our channel and feel free to share your views in the comment section and chat section, how you like the video and how you like this particular session. Thank you so much, Sansa, once again. And that's about it from our side. Have a good day, guys, and do share your
So bye
feedback. Thank
guys. That was really good. A pleasure to know you. Have a have a great day. Bye.
Bye bye, guys. Bye.